room of inner dimensions 3 meter by 7 meter is covered with a RCC slab of thickness 120 mm, resting on the masonry walls 300 mm thickness on either sides. Main reinforcement for the slab is 10 mm dia at 120 mm center to center, and distribution reinforcement is 8 mm dia at 150 mm center to center. Grade of concrete is M20 and steel grade is Fe415. Alternate main bars are cranked on both sides. Assume top cover, bottom cover and side cover is 25 mm. Draw the following to a suitable scale. Number 1. Plan of the reinforcement. Cross section along the longer span. Number 3. Cross section along the shorter span. Room inner dimensions are 3 meter by 7 meter. Say this is the room, 3 meter, 7 meter. Inner dimensions means clear spans. Clear span in the shorter direction is 3 meter. In the longer direction, clear span is 7 meter. And RCC slab thickness is thickness of RCC slab is 120 mm. And the main reinforcement is 10 mm dia at 120 mm center to center, and distribution reinforcement is 8 mm dia at 150 mm center to center. Here the condition given is cranked bars are provided alternatively. So in the shorter direction, the main straight bar is provided like this. After this is a cranked bar, and the bar is cranked on both sides. This is main straight bar, and again cranked bar on both sides, main straight bar and cranked bar. See, this is the spacing between the straight bars. This is the spacing between cranked bars. Spacing between straight bars. Spacing between cranked bars. This is the main bar, and the cranked bar is placed like this, and the distribution bars are placed like this. Hanger bars are provided here to support this cranked bars. Main bars are of 10 mm dia at 3 mm center to center. These cranked bars are 8 mm dia at 150 mm center to center. These are the hanger bars. Three numbers. So 8 mm dia hanger bars are provided on either side. See, these are also hanger bars. Three numbers, 8 mm dia. Now calculate the length of main straight bar, length of cranked bar, and length of distribution bars, length of hanger bars. So A bar is main straight bar, so length of main straight bar is provided in the shorter direction. Therefore, the length of main straight bar LMS is equal to clear span in the short direction 3000 plus support widths on both sides is 300 mm on both sides, 2 into 300, and deduct the end covers on both sides, 2 into 25. 3550 mm. Now calculate the number of straight bars required. NMS is equal to total length of the slab in longer direction excluding cover divided by center to center spacing of main straight bars plus 1. Total length of the slab in longer direction is clear span in the longer direction 7000 plus 2 into support width 300 minus end covers 2 times end covers divided by spacing of main straight bars are 120 mm. I already told that the spacing is provided for main bars is twice the actual spacing. Why? Because we provide the straight bars alternatively as well as cranked bar. This is the arrangement of main reinforcement in the shorter span. Main straight bar and cranked bar, main straight bar, cranked bar, main straight bar, cranked bar. So the spacing for two main straight bars is actual spacing into 2. Similarly for cranked bars, spacing is 2 times the given spacing. 2 times spacing. 2 into 120 mm per center to center plus 1. Number of main straight bars is equal to 32.45. Say NMS is equal to second bar is main cranked bar. The cranked bar is having the cranks on the either side. Length of main cranked bar. The length of main cranked bar is equal to length of main straight bar, which is equal to LMS plus crank allowance on the either side. So this is the one crank allowance, here another crank allowance. So 2 into 0.414 times overall depth is 120 mm minus 2 times 25 minus dia by 2 minus dia by 2. This is the cover on the top and bottom portion of the slab. Take top and bottom cover is 20 mm. So this is the bar having the 10 mm dia. This is D, which is equal to total depth 120 minus this cover minus this cover. 120 minus 2 into 20 mm 20 mm. Therefore 2 into 20 minus center of this reinforcement is 10 by 2. Similarly here 10 by 2. 3550 plus 2 into 0.414 into 70. Total length of the main cranked bar is 3607.96. You write this length as 3608 mm. Correct this top and bottom cover is 20 mm instead 25 mm given in the question. In the plan of a slab, this is the shorter span, this is the 7-meter longer span. We have found out the number of main straight bars are 33. We are providing the main bars like this. Total number of straight bars are 33. Main cranked bars are 33 minus 1, 32. Therefore, number of main cranked bars is equal to number of main straight bars minus 1. See the arrangement like this. Total, we get 1 bar less than this number of straight bars. 33 minus 1. Next bar is distribution bar. This bar is provided in the longer span. Length of distribution bar is equal to LD is equal to clear span in the longitudinal direction plus 2 into 300 minus 2 into end cover. Which is equal to 7550 mm. Number of distribution bars is equal to total length of the slab in the shorter direction excluding the end cover divided by center to center spacing of distribution bars plus 1. The number of distribution bars in D is equal to 3000, which is the clear span in shorter direction, plus 2 into bearings minus 2 into end cover divided by spacing of distribution bars is 150 mm plus 1. 24.667. You write it 25 number of distribution bars are to be provided in the longitudinal span direction. Next bar is hanger bar. Hanger bar is provided on the top portion to support the cranked bars. Length of hanger bar say LH, which is provided along the longer span, which is equal to length of the distribution bar. Therefore, H is equal to 7000 plus 2 into 300 minus 2 into end covers, which is equal to 7550 mm. Our number of hanger bars is equal to 3 plus 3. See, this is a cranked bar, this is a main straight bar, these are the distribution bars. One, two, three. These are the hanger bars. Similarly, this side also 3 hanger bars are provided. 1, 2, 3. 3 plus 3. 6 hanger bars are to be provided. Prepare the bar bending schedule from the length of different bars and numbers on the given data in the question. First one is main straight bar. Shape of the main straight bar is straight and diameter of this bar is 10 mm. Total 33 number of bars are required, and total length of the beam is 3.550 meters. Total length is equal to number of bars into length of the bar, 117.150 meters. Weight of the bar is equal to dia of bar whole square divided by 162.2, 0.616. Total weight is equal to total length of the bar into weight of the bar. 8th column is equal to 6th column into 7th column. Value 72.164 kg. Second one is main cranked bar. This is the shape of cranked bar. Diameter is 10 mm. Number of bars is 32. Total length is 3.608. Length of the bar is 3.608. Total length is 32 into 3.608. 115.456 meters. Weight of the bar is 0.616. Total weight is equal to 71.120 meters kgs. We have given notations for these bars: main straight bar A, main cranked bar B, and distribution bar is C. It is a straight bar. Diameter is 8 mm and number of bars are 25. Length of the bar is 7.550 meter. Total length is equal to 188.750 meters. Weight of the bar is 8 square by 162.2, 0.394 kg per meter. Total weight is equal to 188.75 into 0.394, 74.367 kgs. Next bar is hanger bar. D. Hanger bar. It is also a straight bar. Diameter is 8 mm. Number of bars are 6. Total length of the bar is 7.550. Total length of the bar is 6 into 7.55, 45.300. Weight per meter is 8 square by 162.2, 0.394. Total weight is equal to 17.848 kgs. Now calculate the total weight of the steel by adding these values. Total weight of steel is equal to 235.499 kgs.